Hello, everyone. My name is Nandan Tammineedi. I am a lead engineer at Ascend.io. I'm really honored and excited to have Zach Mitchell, who is a senior big data architect at AWS, joining us today. And he will be talking about AWS Glue and the benefits of the platform. So the agenda for today is I will be going over the Ascend platform overview and give you a brief introduction. I'll be talking about some of the recent architectural improvements. And then I will hand it over to Zach, and he will be talking about AWS Glue. And then we'll open it up for Q&A. So with that, let's talk briefly about the Ascend platform. So Ascend is a fully managed data engineering platform. Users of the platform can ingest almost any kind of data, event data, transaction data, operational data, from a wide variety of sources. So, think about streaming systems like Kinesis, traditional databases like MySQL or Postgres, APIs like Salesforce, files on a blob store, and other types of apps. Once this data is ingested, our platform offers the ability to transform this data using a wide variety of interfaces and programming languages, such as SQL, Python, and Scala code. And once this data has been transformed, which is typically some combination of cleaning, annotating, aggregating, joining this data, it can be delivered to the destination of your choice, which could be a warehouse like Redshift. It could be an object store like S3, or a traditional database like MySQL or Postgres. Data can also be consumed through a standard suite of BI tools like Tableau or Looker. The key point here is that this entire pipeline workflow is defined declaratively, either through our web UI or through the API and SDK. So let's take you back to a short history of, to lay the foundation for some of the changes that we've made. So going back 18 or even 24 months ago, the platform was built around fairly standard AWS building blocks, right? So we're talking about a collection of microservices running on EC2, managed and orchestrated with EKS as a Kubernetes offering, and then S3 for persistence and RDS for metadata. The key thing here is our transform processing engine was exclusively Spark. So our users had the ability to specify transform logic using Spark SQL, PySpark, or Scala. And here's a different way of looking at this layered architecture. So what we used to have is essentially one flavor of data plane, with the compute engine being Spark, which is essentially Ascend's Spark offering running on Kubernetes. And the persistence layer was an object store, which in the case of AWS is S3. There's also a control layer that sits on top of this that provides all of the advanced Ascend functionality, like ingestion schedules, partition management, lineage tracking, the code and data integrity checks that we perform, data profiling, and so on. So fast forward a few months, we built integrations with other managed Spark providers, most notably Databricks. The key shift in our architecture came with the offering of what we called FlexCode connectors. This was essentially a redesign of our connector API and our connector framework to make building connectors a lot easier, to the point where a single engineer can now develop a connector to something like a data warehouse or an API source in 1 week, and typically in the order of a day or two. And as we built these connectors, we started to see that there was a big overlap between some of these technologies that we were connecting to and the transform engines that typically process the data. So if you think about a data lake like Lake Formation or a data warehouse like Redshift, we started to see an overlap between the types of connectors, the types of sources we were reading from or writing to, right? And the actual runtime platform and the transform engine that we were using to process the data. And that led us to rethink what a data plane actually means, right? So we've come to recognize that over time, as these cloud offerings for orchestration of Spark, like AWS Glue, and data warehouses like Redshift, and even data catalogs like the Glue catalog, get increasingly sophisticated and much more easy to use and spin up and provision and scale. Our users actually want the benefits of using these platforms, but at the same time, they also want the benefits of the Ascend platform and also the contextual awareness that ties all of these pipeline components together. And most importantly, the productivity that the Ascend platform brings to their day-to-day operations and building out new use cases. So what we realized is that we can bring this new data plane architecture to our users, where we enable them to use these cloud technologies without sacrificing the benefits of the Ascend platform. And we also find that there's a natural alignment between this new shift and some of the core principles of data mesh architecture. And with that, I'd like to announce the integration of the Ascend product with AWS Glue. We will be accepting signups for early access. And with that, I'd like to hand it over to Zach, who will be talking about Glue. Thank you.
Thanks, Nandan. Thanks for that introduction. Just to recap, as much of Ascend's audience might not know what Glue is, I'd like to first go through a recap of what is AWS Glue. In short, AWS Glue is a serverless execution engine built on Apache Spark and Python. Because it's serverless, there's nothing to manage, no clusters to maintain or provision, and a lot less friction when setting up a traditional Spark environment on which to run applications such as Ascend.io. So how does Glue work? First, it's fast, it's open, it's scalable. It is the same Spark you know and love elsewhere, but built on a new job manager. Starting with Glue 2.0, we built our own job manager to submit jobs to a virtual cluster. This virtual cluster reduced start times and reduce the variance in your start times to give your jobs more predictability and graceful degradation when provisioning capacity. Traditionally, with the old versions of Glue 1.0, your jobs would start in typically under a minute, assuming we had warm capacity. When we did not, however, your jobs could take 8 to 10 minutes to provision. This variation led to a massive amount of unpredictability and prevented you from solving some of your business problems with Glue. With Glue 2.0, we re-engineered that backend. And now the majority of our jobs start in just 10 seconds, with 35 seconds being the long tail end of that for a cold start. Because we have this predictable start time in very, very low latency, it also opens us up to a lot of new opportunities, places and ways we can use Spark that weren't available before, all while maintaining significant cost savings and reliability. Additionally, with Glue 3.0, we brought Spark 3 into Glue. Now, we didn't just bring in Spark 3.0, we added a bunch of optimizations to help with most of your ETL tasks, taking row-based data, your raw data, such as CSV, JSON, and writing it into columnar formats, such as Parquet and ORC. Now, with that, we did a few things. We put in some C++ based SIMD vectorized readers. These are super low level readers for these row-based formats. allowing us to reduce significant amounts of compute when processing them. We put in columnar data structures into our memory so that we can reduce the amount of overhead it takes to translate from what's in Spark's memory into the output you're seeking. And again, this engine of Glue 3.0 is based on the same execution model as Glue 2, as discussed in the previous slide. What you can see is there was significant benefit in these optimizations, such that we have over 50% improvement in some of our runtimes. So Glue 3.0 is now 2.5 times faster than 2.0 when properly optimized. How did we do all this? So let's talk about the scalable execution model, because it's nice that we have a good managed working Spark, but the execution model is really what matters here as we're talking about Ascend, because Glue typically takes a job and submits it to a job manager. Now, just like anything else in Spark, that job manager has to submit work to workers in a cluster. And so in Spark, of course, jobs are divided into stages or pieces of work, and data is divided into partitions. Those partitions are taken through each stage with processes we call tasks. Now, the job manager, its entire purpose is to schedule the tasks on workers. This is the benefit of Glue. Glue is able to scale to thousands of workers with that single job manager and allow you to only pay for compute that is used. Now, in traditional Spark, this is the goal, but it's difficult, because if I know I'm going to have X amount of data, I can provision Y amount of compute, but data fluctuates. Data is hard to predict. Times of day, seasonality, data skew are all problems that you typically go through when trying to figure out how big does my Spark cluster need to be. Additionally, in order to reduce cost, we spend a lot of engineering time tuning that cluster, monitoring for cost controls, and just trying to squeeze every penny out that we can. And this all leads to over provisioning, extra cost, and performance variation, because you're changing the code for tuning. The data is constantly changing. And so you have to give and take, and usually you over provision to ensure that the thing works. Well, at reInvent in December, we announced Glue auto scaling into preview. With a typical Glue job, this used to be your compute. You would provision the entirety of your compute at the beginning of your job, and you would run your job and all of your compute would die. With auto scaling, we can provision just the compute we need as we need it and tear it down when it's no longer necessary. So if we take something as simple as a list operation, that needs a single execute. And so that executor is going to go until your list operation is complete. Once tasks start forming on the other executors, such as a wide transform, we'll scale those up rapidly with our new backend. And that wide transform, as it completes and we have fewer and fewer tasks to complete on fewer executors, we'll drop the ones that are no longer necessary. And so you don't pay for any idle compute. This leads to a significant amount of cost savings. This leads to a significant benefit in giving you as a customer compute that you only pay for what you use. So how does this integrate with Ascend? How do we take Glue's job system and how do we plug it into Ascend.io and other platforms like it? At reInvent, we also announced Glue Interactive Sessions. And Glue Interactive Sessions is the method by which we will plug into Ascend.io. Now, before interactive sessions, if I wanted to run interactive queries, or I wanted to allow an application, such as Ascend, to interact with a Spark environment in Glue, I would require a lot of pre-provisioning. On average, it would be 10 to 15 minutes before I could run a single query. That cluster then would have to stay up and run for a long period of time. And it would be very costly and it would be slow. Now, because of that cost, oftentimes you will have multiple tasks and jobs running on a single cluster in order to save resources and money. Now, this causes a noisy neighbor problem. If 3 users are using a cluster and one user takes 90% of the compute, that leaves 10% for the other two users, often causing out of memory exceptions and other things that people are not prepared for. With interactive sessions, we take that same Glue 2.0 and 3.0 backend, and we back it with an elegant API that allows me to provision interactive compute within seconds. Your average first time to query is less than a minute from having to bring up something like a notebook or Ascend and begin running your executions. Now, the benefit of this is companies like Ascend can begin integrating their products into Spark without having to think about compute, without having to worry about where it's coming from or how big it can get, because Glue handles all of that for you. And all they have to do is simply write code to talk back and forth. Now, interactive sessions, of course, was built to be able to use by developers, but again, also these other platforms. Ascend is one of the development tools of choice. Obviously, we launched it originally with Jupyter, and you can continue to use it in many different ways. I don't think we've scratched the surface on the number of ways in which interactive sessions will be used yet. Again, because it allows for interactivity, you get rapid development of both integration into something like Glue and Spark, but also you get rapid iteration on your data pipelines and transforms. You get to see very quickly how things are working and not. And of course, it's built in costs because you only pay for what you use. The additional benefit of using AWS Glue is its native integration with AWS Lake Formation. AWS Lake Formation provides enterprise scale data governance. So Amazon S3 is the most popular choice on which to build data lakes. It provides unmatched durability, availability, and scalability. It's easy to use with intelligent cost optimizations and tiering. There are more ways to get data in and out of S3 than anything else, and more object level access controls. And it's got the broadest portfolio of analytics tools that interface with it. It has, the best in class security, compliance, and auditing capabilities as well. Now, Lake Formation simplifies some of the benefits, simplifies the challenges associated with building data lakes. Data lakes have operational challenges. You're required to ingest data and manage that data at scale. And management at scale is incredibly difficult and incredibly time consuming. Just trying to identify and find all of your data at that scale is mind-boggling. Security and governance is extraordinarily hard as well. Once you have identified the data, how do I get it? How do I use it? How do I secure it? Who gets access to what? And how do I address those issues that come along with the regulatory challenges of running a business in the modern age? And finally, of course, Lake Formation helps simplify the complex self-service models that everybody wants. Everybody wants all of the freedom to give everybody the data they need access to use in the way they need, including with something like Ascend. However, because of increasing regulatory pressure, data is typically locked down tighter and tighter than ever before. And so granting access to highly sensitive data with the wide variety of tools became a challenge. With Lake Formation, this challenge doesn't have to exist for your Ascend users, because Ascend being built on Glue and interactive sessions allows for that data governance, allows for that simple, highly scalable, highly effective data governance strategy with Lake Formation, backed by your S3 data lake. So you get a single place to manage your access. You still get your open file formats. We're not asking you to change any formats. You don't have to. They all just work. You get efficient and easy sharing between accounts, whether that's within other lines of business in your organization or to third parties such as partners and vendors. Again, you get an ecosystem of tools that are already built within AWS, as well as partners like Ascend that bring significant value to these particular systems. And of course, Lake Formation makes things cost effective because it's built on S3 and you have all of these choices for intelligent tiering and storage. You have an incredibly comprehensive management system for dealing with data cost as your data grows and scales. Thank you very much for your time. I'm really looking forward to seeing what you guys build with Ascend on AWS Glue. It is now Q&A time, So I'd like to invite Nandan to come back and let's answer your questions.